looking at group 7 elements. Group 7 elements are called the halogens. This means that they form salts. They're good at making salts. Right, it's the ones in yellow. So this is group 7 here. Fluorine, chlorine, get the mouse, fluorine, chlorine, bromine, iodine, and astatine. Right, you've got to know a few things. Right, we can say at room temperature, fluorine's a gas, liquid, solid, solid. Let's quickly go through the colors. So I remember it as yellow, green, you greedy, red, brown fox, red, brown fox, and it's gonna be grey. So basically they get darker, and astatine will be probably dark grey. So it's not dark grey, it's black, and it's radioactive, but that's what you need to know. Right, now let's look at the reactivity. What happens when you go, let me go to the other side, be careful with that. So when you go down here, the group, what happens? The world's greatest drawer. What happens to reactivity? Right, reactivity as it reactivity goes down, it decreases. And what's the reason? Because, and just learn it if they ask you, because the extra, oh, not extra, the extra electron it needs to gain, the extra electron it needs to gain becomes more difficult, becomes harder or more difficult, because there's less of an attraction, because it's further away. How should we do it? Right, okay, let's try fluorine. Let's compare fluorine to chlorine. So I'll try to do it this way so you can see it. So fluorine's got 9, 2 there, and then the next shell has got 7. So let me get this so we can see it. 1, 2, you're only allowed 2 there. 2, 3, 4, 5, 6, 7, 8, 9. So what I'm going to do, so watch this to make it the same, so you can see it. I don't think it'll copy like that. No. So copy and paste. Right, there we are. So that's fluorine. Now, if you look at chlorine, it's got 17. So I need to complete this electron shell. So now I've got 2 plus 8, which is 10. I need 7 more. So I need to draw another electron shell. So right, I need 7 more. So let's add 7 more. 1, 2, 3, 4, 5, 6, 7. Right, I need to remove this fluorine and relabel that chlorine. Let's do that. There you go. Now, if you look, and this is the key part to it, I need this electron to come into this space here. Now, I've got a positive force here, electrons are negative, so these two are attracting this electron, and this positive nuclei, or nucleus, should I say, is attracting it. Now, if you look at the distance, it's relatively short. At this level, that's all you need to know. It's relatively short, and there's less electrons in between shielding it. Now, with this one, this electron needs to go here. But if you look at the distance, it's much bigger. So this positive attraction, although slightly bigger, doesn't have a strong enough pull on this, because you've got other electrons pushing it away, repelling it away. So that's why as you go down, the reactivity decreases. Right, that's one property you need to know. And what you can also know is, what do you notice about the melting points? So we can write down here the melting and boiling points increase as you go down the group. So as you go down the group, the melting and boiling points increase. As you go down the group, reactivity increases. Another property what would be useful just to put into your brain is the relative they get heavier. Relative atomic mass increases as you go down. As you go down the group. Right now, that's that bit. Now we need to move on. What type of compound? So first of all, when halogens react with non-metals, they form covalent compounds, simple molecular covalent compounds. Right, so when they react with non-metals, they form covalent compounds, and these have a simple molecular structure. Right, now the next one is when they react with non-metals, when they react with metals, they form ionic compounds. With ionic structure. So how should we do this? Right, let me just make a few points with you. So halides form -1, -1 ions. Okay, so what you're gonna have is you're gonna have F minus, chlorine minus, bromine minus, iodine minus. We don't use acetylene, it's like a radioactive substance in the lab, so you're not going to see that. Right now, so for example, if I reacted, let's do an example. If I reacted sodium with chlorine, and remember chlorine comes in pairs, This little 2 tells you it's coming around as a diatomic molecule. Okay, so you have a solid here and a gas here. And when they react, you end up with sodium chloride. Right, but we've not. Right, let me come up here and try something with you. NaCl. I know sodium forms a +1 ion and chlorine forms a -1 ion. I'm not interested in the signs. Look, I can ignore them too. I'm interested in the 1. Because they're both the same, I can ignore them. They can disappear. So my formula will be NaCl, right? And it's a solid. But now I need to balance it. I've got 2 chlorines. Look at the mouse. I've got 2 chlorines here. So I need 2 chlorines here. I've only got 1 there. So I stick a 2 in front. So now I've got 2 chlorines and 2 chlorines. But I've only got 1 sodium. But I've got 2 sodiums here. So I need to stick a 2 in the front. Now that's balanced. What would happen if I did magnesium metal plus, let's just do magnesium fluoride. What would happen? I would end up with magnesium fluoride. So I go to the side, put magnesium there, fluorine there. I know magnesium is in group 2, so it forms a +2 ion, or 2 plus ion, +2 ion. Well, I put 2 plus, I think it should be +2. I put +2, it should be 2 plus. Let me just rewrite that not to cause confusion. And this is 1 minus. Now, I'm not interested in the signs. All I'm interested in is this. That's a 2, that's a 1. I cross them over. I cross them over. This is a crossover method. Yeah, I've seen someone do this. So Mg2F1. Now this 1 here, we don't need, so we can get rid of that. So it'll be Mg2F. So I come down here and I put Mg2F. That is my no, what am I doing? Oh my goodness me. Am I with it or not? Let's start that again. I did that all wrong. Well, let's try that again. We need to get rid of that and that. So I'm looking for the eraser, and is it still working? Yes, it is. Right. Right. Let's take that 2 there. Let's bring that 1 down here. I don't need this one. That's what I was doing. So we can get rid of that and that. So now it's Mg F2. It didn't feel right, that. Right. Now I've got 2 fluorines here. I've got 2 fluorines here. I've got 1 magnesium and 1 magnesium, so they're balanced out. So that's it. It's MgF2. Right. Is there anything else? So now these compounds that are formed here are called halide. You'll hear the word halide salts. Halide just means that the halogens. Right. And they have ionic structures, yeah. So they form, what did we say? So let's make a statement here. Halogens react with metals to give ionic compounds. Right, basically they form ions. Right, last thing, halogens can take the place or displace less reactive halogens. What does that mean? Now, what that means is, let me just see if I can get hold of, if I can do that here, it might make it easier to see. Right, okay. So this is most reactive, and all the way down, this is least reactive. Right, so if I had sodium iodide and I reacted chlorine with it, who's stronger? Is chlorine or iodine stronger? Chlorine's there, iodine's there. So chlorine's stronger, so what happens is chlorine is going to go over and kick out iodine and take its place. So you're going to end up with sodium chloride, right? And then this iodine is going to get kicked out and it becomes iodine on its own. And because it's diatomic, because it runs around in twos, you have that. Now we have to go balance it. So we've got one chlorine here, two here, so we need two. We need two chlorines there. We've got two iodines, two sodiums, but only one of each, so we stick a 2 there. So our reaction is, our chemical equation is 2NaI plus Cl2 gives 2NaCl plus I2. Now, the thing with this is, let me just try to do this and see if we can figure this one out. Yeah, if I had sodium chloride and I put chlorine, we're going to end up with sodium chloride and chlorine. There's no reaction. And why? Because, let's write this down, because a halogen cannot displace itself, cannot take its own place. What would happen if you had this? What if I had sodium chloride and I put in iodine? Now I know chlorine is stronger. Oh, that's not good, is it? I know iodine is stronger. Sorry, chlorine is stronger. Let me get this right. So chlorine is stronger, so I'm not going to get a reaction. So I'm going to end up with sodium. Oh, did I just do that? Yes, I did. I'm going to end up with, let me get that right. So you're going to get no reaction because we'll put it that way. Iodine is less reactive than chlorine. And that's all you have to do. So what halogens are trying to do is have a full outer shell. How do we do that? It needs to add one more electron. It needs to add one more electron what happens to form a -1 or 1 minus ion. Right, that's it. So everything is there for group 7. So let's just quickly fly through that. So you've got group 7 are called halogens. At room temperature, they are gas, gas, liquid, solid, solid, yellow, green, red, brown, grey. You greedy red, brown fox jumping over a grey fence. Chasing, I don't know, a black chicken or something. But yellow, green, red, brown, grey, black. Right, why does the reactivity, so there's 3 properties that you need to know. Why does the reactivity decrease? Because the extra electron that each atom needs to gain, it becomes harder because there's less of an attraction. Right, the next property, melting and boiling points increase, and you can tell from gas, liquid, solid. You can tell that this here, the solid has got a higher boiling point and melting point. And the relative atomic mass increases as you go down. You can see from 9, 17, 35, 53, and so on. Right, when halogens react with nonmetals, they form covalent compounds. They have a simple molecular structure. Right, when halides form, they have a -1 ion. They react with metals to give ionic compounds. Halogens can displace less reactive halogens. And that's down here. We did this down here. We said sodium iodide reacts with chlorine. The chlorine is more reactive, stronger, so it kicks out the iodine or the iodide ion and the iodide ion becomes iodine, and the chlorine becomes chloride ion. And this is what your equation is, and you'll have to learn to balance it. And sometimes you'll get no reaction because if it's the same halogen, it can't displace itself. If it's lower down the table, it's not as reactive, so it can't displace itself. Right, okay, done. That was a long one, that.